P-rep designs are commonly used in early generation breeding trials where there are a large number of treatments to be screened and not much material available. In the past, single replications of treatments were used in conjunction with multiple replications of check or standard treatments to provide an estimate of error. P-rep designs also generate error degrees of freedom by duplicating some of the treatments, usually in addition to the inclusion of standards. P-rep designs can be generated for single and multiple locations. We'll begin demonstrating CycDesign using small illustrative examples for ease of explanation. Also, for simplicity, we will initially focus on block designs rather than row-column designs. Typically, however, trials are laid out in a rectangular grid of experimental units, that is, in rows and columns, rather than in blocks. In this video, I'll show you how to produce both single-location and multi-location P-rep designs, laid out in either blocks or rows and columns, and with or without standards. I'll also show you how to generate a spatial row-column P-rep design to ensure good separation of duplicated treatments and standards. We'll begin by walking through a simple example of a single-location P-rep block design with 12 treatments and 3 blocks of size 6. From the main menu, click Design, then select Partially Replicated to open the menu for generating P-rep designs. If needed, click the top button so it displays Block Design, then click Parameters. We'll set the number of treatments to 12. The number of standard types to 0, and the number of locations to 1. Note that standards, for example, check entries or controls, can be incorporated into P-rep designs. These are replicated more frequently than the treatments. In an augmented P-rep design, a design for a single location, all treatments are unreplicated except for the standard types. Click Next to set further parameters. In this window, we set the minimum number of replications of the treatments across the whole design. In a single location P-rep design, not all treatments have to be replicated. In this design mock-up, the white treatments are unreplicated, so they only occur once. In a multi-location P-rep design, at each location, some treatments occur once, some occur more than once, and others do not occur at all. Now we set the number of units per block, which in our example is 6. Click Next to open the final window for parameter setting. Set the number of blocks per location to 3. Notice that the number of duplicates has automatically changed to 6. This is because our design of 3 blocks of size 6 provides a total of 18 experimental units to which our 12 treatments are randomly assigned. This enables 6 of the 12 treatments to be duplicated. I'll click Next to close this window and return to the first menu. To begin generating the design, click Next. Wait for a while to see if the efficiency factor improves. When this number stops updating, we can click Next to randomize the design. In the randomization output window, ensure Randomize is selected and set number of randomizations to 1 to produce 1 randomization of our design. Click Next to generate the design, which opens automatically. The generated design is at the bottom of the log file. Also included in the log file are details of the design and its parameters, the random number seeds used to generate the design, and the average efficiency factor of the design. In this example, assume there are 4 locations, 3 blocks of size 5 per location, and 16 treatments, each of which is to be replicated at least 3 times across the whole design. Therefore, in the design parameter windows, set number of treatments to 16, number of standard types to 0, and number of locations to 4. Set the number of replications to 3, and number of units per block to 5. Number of blocks per location will be 3, And for the final parameter, number of duplicates per location, we have a choice of settings, 0 to 4. Let's duplicate 2 treatments per location. Click Next and keep your eye on the average efficiency factor. Give this a bit of time to stabilize, perhaps 30 seconds to 2 minutes. When this number stops updating, meaning that there's no or only a little more improvement to be gained, we can click Next to randomize the design. Leave these settings as they are, then click Next to generate the design. In this example, the treatments are replicated either 3 or 4 times. More generally, in a multi-location PREP design, individual treatments are replicated either R or R+1 times. Note that in this example, none of the treatments occur at every location. This can happen when material is scarce and needs to be spread thinly across locations. Furthermore, to generate error degrees of freedom, some treatments are duplicated at locations rather than allocating them to each location. In large trials, this is a better way to obtain adequate degrees of freedom than the alternative of using up space with many standards. With more resources, such a compromise can usually be avoided. At the end of this video, I'll show you a real-life example that has many more treatments laid out in rows and columns and has spatial improvement. Now let's modify the previous design to include 2 standard types, denoted by S1 and S2, each of which we want to occur 3 times per location. Click Parameters, then set the number of standard types to 2. Now click Edit Standards and enter the required number of standards per location. We want 3 replications. To accommodate these standards in our design, we either must change the dimensions of the block design, that is, increase the number of blocks and/or increase the number of units per block, or decrease the number of times our treatments are replicated across the design. Reducing replication is never ideal, so if possible, you should aim to increase the dimensions of the block design, preferably by increasing the units per block. Let's assume we can increase the units per block from 5 to 7, giving us 6 more plots per location. This will enable us to accommodate the 6 standards per location, 2 standard types by 3 reps, without reducing the amount of possible treatment replications. Finally, we'll set the number of blocks per location to 3 and the number of duplicates to 2. I'll click Next twice to begin generating the design and wait for a while to see if the efficiency factor improves. And here's our design. The 2 standards, S1 and S2, are replicated 3 times per location, whereas the 16 treatments are replicated at least 3 times across the whole design. When generating a PREP block design with standards, CycDesign will set out the standards at each location such that they occur as evenly as possible within the blocks. In this particular example, each standard type appears exactly once in every block. Until now, we've only considered PREP designs laid out in blocks. Let's look at one laid out in rows and columns at each location. As before, let's assume there are 4 locations, 16 treatments, each of which is to be replicated at least 3 times across the whole design, and 2 standard types, each of which is to be replicated 3 times per location. But this time, within each location, the design is to be arranged in a 5-row by 4-column grid. In the partially replicated design menu, toggle the top button to display row-column design. Click Parameters and set number of treatments to 16, number of standard types to 2. Edit standards to 3 for each standard type. Number of locations is 4. Number of replications is 3. Number of rows 5. And number of columns 4. For the final parameter, number of duplicates per location, let's duplicate 3 treatments per location. Notice that the 5th button is now enabled. This button toggles between spatial and non-spatial designs. A common problem with classical row-column designs is that replications of the individual treatments may be clustered together. A spatial row-column PREP design takes the distribution and separation of the treatments across the rows and columns into account, generating a design that is more robust to spatial trends and environmental heterogeneity across the row-column grid. We'll set this to generate a spatial design. Click Next, and CycDesign will run through its iterative procedure to optimize the standards, ensuring they are evenly spread across the rows and columns. When this process is stabilized, click Spatial. CycDesign will now run through its algorithm to improve the spatial properties of the design. When the updating process is stabilized, click Next. I'll leave these options as they are and click Next to generate the design. And here's our 4-location spatial row-column PREP design, augmented with 2 standards. Notice that the standards have been spread across the rows and columns, so that at each location, no more than 2 standards appear in every row and in every column. And when 2 standards appear in the same row or column, they are of different types. The treatment span for duplicates table summarizes how close the duplicated treatments are to each other within a location. For example, a span of 3 for a treatment in the row direction means that its duplicates range over 3 rows. CycDesign's spatial algorithm tries to maximize the overall span of the treatment replications. In our design, at each location, the duplicated treatments span at least 2 columns and at least 3 rows. For our final example, let's look at a much larger multi-location PREP row-column design with spatial improvement. In this trial, 330 lines of winter barley are being tested across 5 locations. Once again, we'll specify a row-column design and set our parameters. We have 330 lines of winter barley. Number of standard types is 1. Click Edit Standards and set this to 24 so that each standard variety is replicated 24 times. We have 5 locations, and each line is replicated 6 times across the entire trial. At each location, the design has 15 rows and 28 columns. Finally, we have 66 duplicated lines. As I said at the beginning, nowadays PREP designs are commonly used in early generation plant breeding trials. Typically, such trials are laid out in a rectangular grid of experimental units, that is, in rows and columns rather than in blocks. CycDesign's spatial algorithm helps to ensure that these designs are robust to spatial trends and environmental heterogeneity across the row-column grid, enabling more reliable estimates of the treatments. For more examples of generating different types of designs and to learn more about spatial designs, check out the links in the video description.